Topic 1, Earth, Sun, Moon Systems. Lesson 2, Earth's Movement in Space. This is on page 16 to 24 of your textbook. Alright, so for our connected here, we're supposed to draw an X on the image to indicate the position of the Sun and which part of Earth is experiencing daytime in this image. So the left half of the Earth is a side that is experiencing daytime. You can see the light on it as opposed to the darkness on the right hand side. And then you need to put your X somewhere to the left of Earth. Obviously yours should be a little bit further away as you have more space. I could have put mine further away, but alas, I did not. So don't put your X marked for the Sun right next to your Earth like it is in mine. Spread it out a little bit, but we know that the Sun is on the left-hand side of the Earth. How Earth moves. The apparent motion of the Sun, Moon, and stars in the sky is a result of the way Earth itself moves through space. Earth, as well as the other planets, moves around the Sun in two separate ways: rotation and revolution. So this is Earth's axis, figure 2. So Earth spins on its axis, rotating from west to east to cause day and night. In this image, you need to shade the part of Earth that is experiencing night. If we see Sun on the right, then the left-hand side is going to be experiencing right. So experiencing night. So the opposite of wherever the light is where it is night. So your shading should be where I've shaded or have this on the left-hand side of the Earth here. So more on rotation. The spinning of Earth on its axis is called rotation. Scientists have named an imaginary line that passes through the North Pole, through the Earth's center to the South Pole. This line is known as Earth's axis. As Earth rotates eastward, the Sun appears to move west across the sky. Because the sunlight can't reach the side of Earth facing away from the Sun, it is night there. It takes Earth about 24 hours to rotate once. As you know, each of these 24-hour cycles is called a day. Revolution, on the other hand, is the movement of one object around each other. So the Earth revolves around the Sun in its own rotation. So it's rotating on its own axis while revolving around the Sun. So one revolution of Earth around the Sun takes 1 year. Like other planets, Earth's path or orbit around the Sun is an ellipse or an oval shape, and the ellipse brings the planet closest to the Sun in January. So you guys should have around this page a Design It. I want you to go ahead and fill out the Design It with your Sun, Earth, Moon models in mind. So the ones that we made in class in groups with the rotating parts. I want you to think about that as you guys are filling out and answering all of the questions for your Design It. The seasons. The extent of seasonal change in any given place on Earth depends on how far away that place is from the equator. Seasonal differences in temperature are dependent on the tilt of Earth's axis. So if the axis were straight up and down relative to Earth's orbit, temperatures in a given area would remain constant year-round, and there would be no seasons. However, Earth's axis is tilted at an angle of 23.5 degrees from the vertical. So here we have seasons, figure 3. Earth's tilted axis affects the strength of sunlight in different places throughout the year. Which month labels the part of the diagram showing the South Pole in darkness? And that's going to be June. So the South Pole receives no sunlight in June, which we can see based on the poles of the North and South. Over in June, it is dark. Day length. The tilt of Earth's axis also affects day length. The hemisphere that is tilted toward the Sun has more hours of day than night. Points on Earth near the poles have the most drastic changes in day length. In Currana, Sweden, the sun remains below the horizon throughout the day for most of January. However, in June, the sun never fully sets. So short days, figure 4. At noon in January, the sun is still low in the sky in Sweden, and you can see it. Gravity and orbits. The force that keeps Earth in orbit around the sun and the moon in orbit around Earth is the same force that prevents you from flying away when you jump. That force is gravity. Gravity. So in the 1600s, an English scientist named Isaac Newton was curious about why the moon orbits Earth. Newton hypothesized that the same force that pulls the moon toward Earth also pulls apples to the ground when they fall from a tree. This force that attracts all objects toward each other is called gravity. Newton's law of universal gravitation states that every object in the universe attracts every other object. Gravity. The strength of the force of gravity between two objects depends on two factors: the masses of the objects and the distance between them. Mass is the amount of matter in an object. Because Earth is so massive, it exerts a much greater force on you than your textbook exerts on you. The measure of the force of gravity on an object is called weight. Gravity is also affected by the distance between two objects. The force of gravity decreases as distance increases. Inertia. If the sun and Earth are constantly pulling on one another because of gravity, why doesn't Earth fall into the sun? Inertia is the tendency of an object to resist a change in motion. So you feel the effects of inertia when you are riding in a car and it stops suddenly, but you keep moving forward. Newton's first law of motion says that an object at rest will stay at rest, and an object in motion will stay in motion with a constant speed and direction unless acted on by a force. All right, so now it's time for our math toolbox, gravity versus distance. Imagine that a spacecraft is leaving Earth's surface. How does the force of gravity between the rocket and the planet change? So here we have the distance from Earth's center at the top and the force of gravity on the spacecraft. So we're going to first create a line graph of the data above. So we're going to go find 1, go up to 4, draw a dot, go to 2, go up to 1, draw a dot, 3, go to 0.44, draw a dot, and 4, go to 0.25, draw a dot, and then connect those dots, and our line graph should look something like this. Now, question 2, what is the force of gravity on the spacecraft at twice the planet's radius from its center? And that's going to be 1 million newtons. What would the force of gravity on the spacecraft be at a distance of 8 radii? And that's 0.06 million newtons. Orbital motion. So the moon travels throughout space at the same speed because of its inertia, but it is constantly changing direction to remain in orbit around Earth. Newton concluded that inertia and gravity combine to keep the moon in orbit around Earth. Planets are held in their elliptical orbits around the sun by the combined forces of gravity and inertia. So here we have orbital motion, figure 6. So gravity and inertia keep the moon in orbit around Earth. Complete the diagram by drawing an arrow to indicate the force of gravity Earth exerts on the moon as it orbits around the sun. It's going to look something like this. You're going to draw an arrow from the moon to the Earth, which is the force of gravity. All right, so now it's time to do our reading check. So what factors affect the strength of the pull of gravity between two objects? Our answer is mass and distance affect the strength of the pull of gravity between two objects. The greater the mass, the greater the pull of gravity. The greater the distance, the weaker the force of gravity. All right, now it's time for a lesson 2 check. So 1, what are the 2 ways Earth moves? And Earth rotates and revolves. It rotates on its axis That's what creates days and nights, and it revolves around the sun, which is what creates our years. 2. What causes the pattern of day and night? What causes the pattern of the seasons? Earth's rotation from west to east causes the pattern of day and night. Earth's tilt and revolution cause the seasons. 3. What happens to the length of the day during the solstices? Why does this occur? Solstices have either the longest amount of light or the shortest amount of light. Solstices occur when either the northern or southern hemisphere is at its strongest tilt toward the sun. The tilt of Earth's axis affects day length. What parts of Earth generally have the highest temperatures? Which have the lowest? What causes the difference? Areas near the poles are colder than areas near the equator. The fact that more direct sunlight strikes the equator means that it receives more energy and experiences higher temperatures than the poles. 5. If you traveled to the moon, what would be the effect on your mass and weight? There would not be any change to my mass on the moon. However, the force of gravity on the moon is 1/6 of Earth's gravity, so my weight would be 1/6 of my weight on Earth. And that finishes lesson 2. Thank you so much.